Okay, this is the last video for the quiz and test review. It's videos, problems number 9, 10, and 11. So a company makes parts for a machine. The lengths of the parts must be within certain limits or they will be rejected. A large number of parts are measured and the mean and standard deviation were calculated as 3.1 and 0.05. So our mean is 3.1, our standard deviation is 0.005. Assuming the data is normally distributed, okay, so they're telling me normally distributed, and 99.7% of the parts were accepted, what are the limits? Well, I see 99, first off, I know it's normal, so I'm gonna draw a normal curve. And they tell me 99.7%. This right here lets me know I'm thinking about the empirical rule. And this means I'm dealing with plus or minus 3 standard deviations because 99.7% is associated with plus or minus 3 standard deviations. So 0, 1, 2, 3, that's the positive, -1, -2, -3. So there's my z-scores. But my actual mean was at 3.1. Well, let's write it this way, 3.1. That's the actual. And I need to know what this value is, and I need to know what this value, and that should be a z. And I need to know this value of 3 up here. So I need to know these two values, +3 and -3. I need to know what those are. So I'm going to start off at 3.1. 3.1, and I'm going to add my standard deviation 3 times, and that'll take me up there. Plus 0.005, plus 0.005, plus 0.005. So 3.115. So that's my upper bound. My lower bound, 3.1 minus 0.005, minus 0.005, minus 0.05, and I get 3.085. So 99.7% of the parts lie between these two values. So my interval is going to be 3.085. That's my lower. And my upper bound is going to be 3.115. That's my upper. And once again, empirical rule, 99.7% are plus or minus 3 standard deviations. The July rainfall in Waterville is 10 millimeters, and the standard deviation is 1.5. So we have a mean of 10, a standard deviation of 1.5. Assume that the data is normally distributed, so we're dealing with a normal. How many days in July would you expect, the daily rainfall to be less than 8.5 millimeters? So this is a complicated problem. It really is. That said, I know you can do it or follow along, and this will make total sense, I think. So first off, our mean here is at 10, and we have 8.5, and they want less. All right, so we're going to shade this way, which is to negative infinity. So this is my lower, this is my upper. So let's go ahead and calculate this. Norm CDF, lower bounds, negative infinity, upper bound is 8.5, mean of 10, standard deviation is 1.5. So let's calculate that. Now remember, we're calculating a probability. That's all we're calculating right now. So second vars, norm CDF, negative infinity, so a bunch of 9s. Lower bound was 8.5. Upper bound, the mean was, let me say that again. Lower bound is negative infinity. Upper bound's 8.5. My mean is 10. And my standard deviation is 1.5. And when I do that, I end up calculating a value of 0.1586. So that's my probability, 0.1586. But they didn't want the probability. They want the expected value. So I need to multiply that by the number of trials, which is going to be n times p. So in this case, 31 days times 0.1586. I need to pause this, and I'll be back. All right, so I'm back. Sorry about that. So 31 times 0.1586 equals 4.9166. So let me explain what we just did here. First off, we calculated the probability that we'd have less than 8.5 millimeters. Well, that probability was almost 16%. Well, if 16% of the time that happens, or if you make 16% of your goals and you shoot 31 times, how many do you expect to make? Well, the number of tries, which is this case was 31 days, times the probability. So we end up with 4.9166. This is our final answer. The June midday temperature in Desertville is 36 degrees, and the standard deviation is 3 degrees. So we have a mean of 36, a standard deviation of 3. Assuming the data is normally distributed, there's our key phrase. It's not geometric, it's not binomial, we're working with a normal. How many days in June would you expect the midday temperature to be between 39 and 42? So once again, this is a problem kind of like the one above, where we're working with a normal, but we have to come back and do an expected value. So real quickly, our mean is here at 36. And we want between 39 and 42. Well, 39 is above 36, 42 is somewhere above that. So I'm looking for this area. So this is my lower bound, this is my upper. So I have a norm CDF of 39, 42, mean 36, standard deviation of 3. So lower, upper, mean, standard deviation. Now when I do this, all I'm calculating is my probability. So I have a norm CDF, second bar is norm CDF. My lower bound is 39. My upper bound is 42. My mean is 36, and my standard deviation is 3. And I end up getting 0.1359. But that's the probability. They didn't ask me for the probability, they asked me for the expected value. So I'm going to go expected values NP. Well, we have 30 days, that's the number of chances. So out of 30 tries, how many, what's the likelihood? So it's about 14%. So 30 times 0.1359 is 4.077. So in the month of June, we expect there to be about 4 days. We would expect there to be about 4 days that are between 39 and 42 degrees centigrade. And that concludes the video. Thank you for watching.